Hello friends, my name is Mert and my graduation project is quality control and classification of marble. Content, we have motivation and methods. We are using the 3D modeling from 2D images for determination of unwanted slope. We are using image processing to measure angles in the corners and using deep learning to classify of the marble. And conclusion. Deep learning and image processing have recently attracted increasing attention in industrial fields. And the aim of this project is provide quality control of the marbles coming off the production line with 3D modeling, deep learning, and image processing methods. We have flowchart here, and we take the input images and then we 3D model of them, then measure angles in the corner, and finally we classify the marbles. 3D modeling. Structure from motion is a photometric range imaging technique for estimating three-dimensional structure from two-dimensional image sequences. Undistorted images. Lens distortion can affect the accuracy of the final reconstruction, so we remove the distortion from each of the images. So then step 2, delete the background. Delete background by image processing to eliminate the unnecessary points. And find points. We use the minimum eigenvalue methods to find the points, detect good features to track. And we are tracking the points which we previously found. Track points which are found in the first image into the second image. Point cloud, we finally got a point cloud, but in this point cloud we have noise, and we delete the noise in the next step, and we have a clear point cloud here, and a few images too belong to point cloud. So 3D modeling is finished here, and we are passing the measuring angles in the corners. We have a marble here with the minor error, and firstly we convert the image RGB then binary. Convert RGB image to grayscale by eliminating the hue and saturation information while retaining the luminance. Then convert the grayscale image to binary image by replacing all pixels in the input image with luminance greater than 0.5 with the value width, mean white, and replacing all other pixels with the value 0, mean black. So we are finding corners from the binary image of the marble. We have the coordinates of the 4 corners, and we are finding the angles between them. As you see, left up is a 87th degree, right type is 95 degree. So we are seeing 2 marble here, and one of them faultless marble and the other is faulty marble. As you see, marbles corners degree must be 90 degree. And as you see, the left marble is faultless marble, and faulty marble, the right side, for example, right type angles is 95 degree. So this marble is faulty. And we are passing the classification of the marble. So we have marble dataset, which includes the 5 labels: beige gray, beige blue dark, beige emperador, travertine notch, travertine classic, and we try to classify them. So firstly, we use the deep learning and then transfer learning to classify the marbles. And deep learning feature extracted from images from dataset, but transfer learning is a little bit different, because transfer learning using ImageNet weights to classify our data. So we left side deep learning accuracies and right side belong to transfer learning accuracies. As you see, transfer learning accuracies better than the deep learning. And then we use the data augmentation. Data augmentation is a strategy that enables practitioners to significantly increase the diversity of the data available for training model without actually collecting new data. Data augmentation techniques such as cropping, padding, and horizontal flipping are commonly used to train large neural networks. And as you see, we use the data augmentation, the best model. We have SquareNet, and we have 2 accuracies here without data augmentation and with data augmentation. As you see, we increase the accuracy from 89% to 91%. So, but is not good. And we used another method. Actually, we found this method. We split the data to model input size. As you see, we have a marble image here, and we are using the input size of the CNN model and split them, and we increase the data actually. So we trained the models with this data, and we got the better accuracy results. For example, VGG16 has 96% accuracy, and we split the data. Actually, we are using the sequential classifier here. Firstly, we used always one classifier to classify our marbles, but actually blue, dark, gray, emperador are subclasses of the beige, and travertine, notch, and classic subclasses of the travertine. And we used the one classifier to split them into beige and travertine. Then other classifier to classify the beige images into blue, dark, gray, emperador, and classify the travertine marbles in classic and notch. So the first classifier result here, as you see in here, we use the best 5 models, and GoogleNet has 94.8% accuracy to classify beige and travertine marbles. And we have classified two upside. We have a SquareNet best result and 93%, and the classifier 3 classified the classical notch marble. We have a 97% on DenseNet model. So we classified the marbles and we create an app to classify marbles automatically. And conclusion, marble was modeled in 3D. Corner angles of the marble were determined. Marble was classified with 87% accuracy using deep learning. Marble was classified with 91% accuracy using transfer learning. Marbles were classified with 96% accuracy using data split method. Application has designed for automatic classification. Thank you for listening.